Hey guys, one more video for today, and this is on organizing real and complex numbers, classifying complex numbers, and properties of complex numbers. As you see here in this diagram at the top of your page, it shows you the complex number system. So the complex number system takes care of all of your numbers, and then your real number system takes care of the numbers inside of the box there. So if you have a number that is pure imaginary, as you can see here, it is also complex. If you have an irrational number, it is also a real number. It is also a complex number. If you have a whole number, it is a whole, an integer, a rational, a real, and a complex. If you have a natural number, it's natural, whole, integer, rational, real, and complex. And if you have a rational number, it is rational, real, and complex. So all numbers are complex. And then where you fall on your number system is what you include. So just a real quick, you might want to jot this down. Natural numbers are your counting numbers, 1, 2, 3, 4, 5, 6, 7, etc. Whole numbers are your natural numbers and zero. So 0, 1, 2, 3, 4, 5, 6, 7. Integers are positive and negative whole numbers and zero. Rational numbers are any numbers that can be written as a fraction. Irrational numbers are non-terminating and non-repeating decimals and non-perfect square roots. And the real numbers include all of those. Pure imaginary is just like I, 5i, 9i, 12i, negative 47i, and then complex is all of the numbers together. So what we're going to do here in problems 1 through 10 is we are going to simplify and then classify. So number 1 is going to be 8i, square root of 64 is 8. It is imaginary because there is a negative under the radical. So it is a pure imaginary number and a complex number. 10i times negative 2i is negative 20i squared, which is positive 20. Positive 20 is a counting number, so natural, and then we work our way out. Whole, integer, rational, real, complex. Square root of 1/9 is 1/3. 1/3 is a fraction. So we have rational, real, and complex. Combining like terms here, we have negative 9 and positive 3i. Simplifying gives us 6 minus 5i. That is going to just be a complex number. It is not pure imaginary because of the 6 with the 5i. So we are going to FOIL 36 plus 20i minus 9i minus 5i squared. That negative 5i squared becomes positive 5. 41 plus 11i is complex. I to the 41st power. Remember, that is going to use that, that chart. So I equals I squared is negative 1, I cubed is negative I, and I to the 4th is 1. So what we're going to do is rewrite that as I to the 4th to the 10th power. 4 times 10 is 40, and then times I to the 1st power. 4 times 10 is 40, plus 1 is 41 to accommodate the problem. I to the 4th is 1, 1 to the 10th power is 1, and 1 times I is I, and I is a pure imaginary and complex number. Number 7, we have negative 8i cubed times I squared times 7, which is negative 8i cubed times negative 7, which is 56i cubed. I cubed is equal to negative I. So that's negative 56i. That is pure imaginary and complex. We have complex conjugates multiplied by each other in number 8. So we're going to square the first minus square the last. And 9 plus 25 is 34. And 34 is natural, whole, integer, rational, real, and complex. I to the 16th is I to the 4th, which is 1 to the 4th, which is 1. So natural, whole, integer, rational, real, and complex. Square root of 150 can be broken down as the square root of 25 times the square root of 6, which is 5 square roots of 6. 5 square roots of 6 is an irrational number because it cannot be broken down as a perfect square. It still has a radical symbol in real and complex. I have some notes for you already on the next page. If you would like to pause your video and go ahead and make note of that, you can. I'm briefly going to talk you through 11 through 18. The commutative property of addition is a switch. So if you notice on problem number 11, what's on the left side and what's on the right side are completely switched. Number 12 is a regroup in parentheses or grouping symbols. What's in grouping symbols on the left is different from what's in the grouping symbols on the right, but the operations don't change and the contents don't change. We know the distributive property. Number on the outside distributes to the numbers on the inside. Number 14, identity property of multiplication means whatever you have, you multiply by 1 to keep the same result. 15, inverse property of addition means you add the opposite to get 0. So if you have 3 minus 8i, you would add the opposite of both terms to end up with 0. Skipping down to problem number 2, the additive inverse is the opposite. The multiplicative inverse is the reciprocal. So the additive inverse of 6i would be negative 6i. The multiplicative inverse would be 1 over 6i. For negative 8 minus 3i, additive is the opposite, 8 plus 3i. Multiplicative inverse is 1 over negative 8 minus 3i. True and false at the bottom. The word closed means when you perform an operation, the result is in the same set of numbers. So the complex set of complex numbers is closed under addition. That is a true statement. And what that looks like is if I have 3 plus 5, that equals 8. Those are all integers. Those are all natural numbers. They stay natural numbers. They stay integers. They stay rational. They stay real. If you are adding complex numbers, they stay complex. The set of complex numbers is closed under division. That is also true. If you divide imaginary numbers, you're going to end up with an imaginary number. All complex numbers are pure imaginary. That is false. We can have 3 plus 2i. That is not pure imaginary. That is just complex. A number cannot be both irrational and complex. That is also false, because we can have 3 plus I square roots of 5. That's irrational and complex. The product of a real number and a complex number is a real number. Also false. We can use the distributive property to show that. 2 times 3 plus 2i is 6 plus 4i. That is not a real number. That is an imaginary number. As always, make your questions box. Let me know what questions you have, and I hope you have a great day.